My name is David C. Taylor. I'm a middle school engineering teacher at Charlotte Latin School, and I'm applying for the Innovation Award in STEM. The title of my project, STEM Innovation Through Project-Based Learning. My project here is broken up into two categories. An 8th grade checker set project that was done this year and an extracurricular robotics program. First, the 8th grade checker set. This was a project that incorporated a large quantity of engineering design skills through fabrication development, using hands-on learning with measurement in a variety of science areas to develop personal checker sets. The first step was teaching CAD. Our students learned 3 different CAD softwares. One was SketchUp, where they learned to design and use the tools to create great temples. They also learned 1-2-3D design by Autodesk, along with actually using the 3D printers, repairing them, supporting the development, etc., and different types of PLA and STL file formats. And then actually making their checkers. They had to make 2 checkers, basically your red and black traditional checker, good versus bad, whatever you want to call it, and designing them in a software that they felt best with, either Tinkercad, 1-2-3D Design, or SketchUp. After they made these checkers, we learned about casting and molding, the science that goes into this, viscosity, endo and exothermic reactions, a lot of the science and chemistry that goes into chemical or materials engineering, looking at flexibility versus stiffness when you're trying to make a cast or a mold. And the students went through this process. And it was a great learning lesson for the students as well as myself. We also went into some fabrication design using Inkscape. Inkscape is a design software. The students first learned this by designing their own personalized bookmarks. And doing this with our Epilogue laser cutter, they learned how to do laser cutting. Another project some of the students did was using 1-2-3D Make to take 3D designs and turn them into layered 2D, 3D figures, such as a hawk, a Batman model, or a giant Superman logo through laser cutting. And then the students obviously made their checker sets out of either cardboard or wood, and they designed these in Inkscape and laser cut them out. And then they put this all together. They casted. This took a lot of time. We learned a lot from about ratios and chemical mixing. And they designed their checker sets and ended up with some final projects, as you can see here. Then our second part is our robotics program. We focus on Sea Perch, was underwater robotics, and sumo bots using Lego EV3s. The Sea Perch robots are made out of PVC pipe. The students learn how to solder, how to use PVC pipes, cement, as well as putting them all together with cables and controllers. The Lego Mindstorms focus more on the design of a chassis and then using sensors with code and doing physical computing to code the robot to push another robot out of the ring. Here are some images of this, of Sea Perch and our Sumo Bot program. Our students learned a lot here, from collaboration to STEM content, flexibility, problem solving, finding those successes, and career opportunities with different backgrounds of engineering and computer science, etc., and using real-world tools in middle school. And this was a lot of fun success for them, and it helps build our program to increase the STEM pipeline. And then for myself, I learned a lot of new skill sets. Through the use of our Fab Lab and going through the Fab Academy training, I'm learning new equipment, being flexible, working with my colleagues to learn new skill sets, analyzing my student interests and pushing our program further within our engineering curriculum. Thank you.